All right, here we are on Online Office Hours. This is Tuesday, June 30th. So in the summer term face-to-face statistics course, and this is dated from last year, but this is just one that I put together last year with some problem sets and some notes from discrete probability distributions. I want to walk through a few of them tonight, talk about the mean, the variance, standard deviation of the ones that we've been working with. Then I might, if I have time or if nobody comes on and asks questions, then I might also bring up some binomial and work with the binomials as well. So it just depends on how much time I've got. So let me push forward, and I hope that my iPad stays with me. My one larger iPad, I normally work with two, so I'm gonna work with just one tonight. So we'll see how it goes. Anyway. All right, so here we are. If you remember from class the other night and from the note sets, by the way, if you're in my class and you're catching this video on demand, if you're not, if you don't show up live, it's fine. Then just remember that tomorrow night, the note set front and back, you need to know all the formulas, all the vocabulary, all the words. You need to be able to pass a quiz on that, because as always, I'm going to have a quiz tomorrow night on the vocabulary and formulas. And then we're going to have a test. I haven't announced it yet, and I'm a little off from my schedule, tentative agenda. We'll have a test on Chapter 3 and Chapter 4, which is probability, and these discrete probability distributions next week. So make sure that you engage with what we're doing in class and engage with the note sets. So here we are. So right there, discrete probability distribution lists each possible value the random variable can assume together with its probability. Now the ones we did last week, we had to build. Once we build them, then we were dealing with the possible outcomes for the data, possible outcomes for the experiment, and then the probabilities associated with each. Must satisfy two conditions. Whoops, sorry. Might have been a little feedback. I had to. Satisfies two conditions. So all the probabilities have to fall between 0 and 1 inclusive. That's normal. All probabilities have to fall between 0 and 1. They don't step outside of that, or it doesn't classify as a probability for us. And the sum of all the probabilities is 1. So there's the mean. We worked with that last week. So you have mu equals, and you have the summation of x times the p of x. And we're going to use the calculator to walk through this tonight to talk about it. I'll go without, and then I'll plug in the calculator and remind you how we did that last week. The variance is just sigma squared equals the summation of parentheses the x value, subtract the mean squared times the probability. So same idea, we're going to use the calculator. I'll also walk through just a few of the terms with it on here if I've got enough room. This is a smaller iPad. Standard deviation, same mathematical relationship. You take the square root of the variance, you've got the standard deviation. So look up in the upper right hand corner here, constructing a discrete probability distribution. This is what we walked through last week. So let x be a discrete random variable with possible values x1, x2, x3. Make a frequency distribution for the possible outcomes. That's what we did. We looked at the proportionality of each of those pieces with the expected outcome. So we find the sum of those frequencies, find the probability of each outcome by dividing the frequency by the sum. We did the sum first last week. Check that each probability is between 0 and 1 inclusive, and that the sum of all probabilities is 1. So make sure it fits the constraints. Okay. Let's look at this probability distribution, right? So we have, in the upper corner, I kept stay with the definition. We need to determine whether this is a probability distribution. So, and this is not Doceri, this is actually on Keynote itself. So let me see how good I can do with this without having overlap. So the summation of all the probabilities has got to equal 1. So if I've got a missing, number one, we can't determine this as a probability distribution. We're going to just say it is 1, and we need to find that missing probability. So we're told that it's 1. So what I'm going to do is take the sum of all the probabilities that we have, and I'll subtract it from 1, and that will give me the one missing. So I'm going to take 0.07 plus 0.20 plus 0.38 plus 0.13. I'm going to subtract all of that from 1. So I've got 1 subtract. I'm just doing this on the calculator real quick. 0.07 plus 0.20 plus 0.38 plus 0.13. And I get 0.222 as my missing. So in other words, if I brought it all back, let me just do a test real quick. Delete that, delete that. Plus 0.22. Yeah. So our missing value here is 0.22. No problem. So we add up all the values. We're looking at the complement. We're looking at one missing probability. Well, we know that the sum of the probabilities equals 1. So all we have to do is add up all the probabilities within this and subtract from 1, and that gives us our missing probability. So a very simple example of some of the things that you might see carrying over from our discussion in class. Okay. So now we're looking at another one. We have a missing probability. Whoa, what will we do? Same as before. So I'm going to go on here and I'm going to add up all of these probabilities. We'll subtract from 1. Since the sum of all these needs to be 1, that's going to give me my missing probability. So I've got 0.05 plus 0.23 plus 0.21 plus 0.17 plus 0.11 plus 0.08, and I get that. Subtract from 1, I get 0.18. So it looks to me like this is 0.18, my missing probability. So 0.02, 0.23, 0.21, 0.17, 0.11 plus 0.08. Yeah. So I added this one to 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 this one, and I took 1 to subtract the sum of. This is not a formula, but of the ones we have, and I get 0.18. So similar to the previous that we just did. And by the way, this looks a little bit different tonight. I decided to come on here and use Restream instead of using Ecamm, and I'm just pushing my iPad screen mirroring 360 is what I'm using, and I'm doing everything on the iPad instead of having a bunch of functions up here. And there's a whole lot less fans on my computer going off tonight. Although this looks like I've locked up. Time out. Oh boy. Let me bring this back up and double check, then we'll move on to the next one. Yep. I'm still okay. I'm just locked up on my screen here. Anyway, so I'm using Restream tonight, and I'm trying to compare Restream and Ecamm. Once again, I've done this for years. They both cost a little bit of money. I like both of them and what they bring to the table. All right, next. Oh boy, what do we have here? Same definitions up in the corner, just to remind. And then I've got a tires problem. A mechanic checked the tire pressures on each car that he worked on for 1 week. The random variable X represents the number of tires that were underinflated. We're going to do several things here. So, number one, I'm going to determine, is this a probability distribution? That's the first thing I'm going to do, number one. Number two, what I'm going to do is I'm going to find the mean. You probably can guess what I'm going to do for number three. I'm going to find the variance, which is going to lead me to the standard deviation. Okay? So, first of all, is this a probability distribution? I may have written that for nothing. Maybe it's not even one. So we've got 30, pull the decimals out for a second, 30, 50, so that's 80, 95, 100. So it works. That's okay. I don't have any eraser on this one. I do have a pointer though. That is a probability distribution, okay. So now, let me find the mean of this. So I'm going to take all of this. Oh my goodness. Gotta be a way to just erase it. Will this do it? No. Highly professional stream. Okay. So let me find the mean. I'm going to try to keep this tucked in here that I have enough room. So So the mean of a probability distribution, a standard probability distribution, the mean is equal to the summation of the x values times the probabilities. As noted in class last week, let me lay this out. This is what it looks like. So I've got the first x value of 0, put a little extra times 0.030, plus 1 times 0.25, plus 2 times 0.25 point. I'm going to go down here below because I'm out of room up there. And I've got plus 3 times 0.15 plus 4 times 0.05. That's what I'm trying to find. I find each one of those and I add them up, and that's going to be my mean. I'm going to do it this way, just using the calculator, just for normal 0 times 0.30, 1 times 0.25. And I'm going to see what I come up with. So let me switch colors, see if this will show up okay for me. For my first term here, this is 0, because 0 times anything is 0. This is 0.25. This 2 times a quarter is 50 cents. 3 times 15 is 0.45. And 4 nickels is 0.20. So I add those up. So I got 50. 0.25 is 0.75. 8595, and then we've got, looks like 1.4. Double check that just to make sure. 0.25 plus 0.5 plus 0.45 plus 0.2 equals, yes, did it in my head correctly. There's my mean. Okay, so how do I do this in the calculator? So what I want to do is I'm going to put these numbers in my calculator real quick. Won't take but a second. Then I'm going to come back and put all this in to an online calculator so you can see it firsthand. So I've got 0, enter 1, 2, 3, 4. 0.3, 0.25, 0.25, 0.15, 0.05. Okay, so I've got those in, so at least I have them in front of me. And let me go here into here, and I'll turn it. Okay, second quit. Okay, so I'm going to go to stat. I'm going to go enter for edit. I'm going to scroll up, hit clear, and enter to clear out everything in L1. And let me hide that along the bottom. There we go. Okay. In the first column, I'm going to put the x values, possible values of the random variable x. So I got 0, 1, 2, 3, 4. That was it. Now I'm going to put my probabilities in, which is 0.3, 0.25, 0.25, 0.15, and 0.05. Double check that, make sure it's all good. 25, 15, 5. Okay, so we go. So I've got everything in there that I need. I'm going to use column 3 to find the mean, right? So I'm going to use column 3 to find the mean. And it's the summation of the x values times the probabilities. Well, my x values are in L1. My probabilities are in L2. So I'm going to go all the way up to where L3 is. And I'm going to put a formula in here. And the only formula I have to have is L1 times L2. L1 times second L2. Enter. Fills in all down below. Are these the same numbers we had? 75, 85, 95. Yeah, comes up to 1.4. So these are the exact same numbers that we had when we worked it out by hand. Just to be sure, I'm going to exit out of the cell sheet, because if I try to do anything else in here, it's going to try to put it in a cell. So I go second mode, and then I go second stat, scroll over to math. You should know this one by heart now. Sum. We're going to take a sum of L3. Be very careful of what you take a sum of. And you get 1.4, which is the same thing that I just got in my head again. That I got in my head before, that I got with the calculator before. So there it is. 1.4 is the mean. Okay, we need 1.4 to find the variance. We're wish I could write on this, but I can't, so I have to go back. Okay, still working with this problem. So now we're going to find the variance. And the way we find the variance is to find the summation of the x value, subtract the mean, which was 1.4 squared, times your probabilities. How does that look like spread across the screen? I'm going to do 1 or 2 here across, and then I'm going to go into the calculator syntax, which I just did verbally a second ago. And so what I'm going to have here is just put the 0, subtract 1.4 squared, times 0.30, plus, I'll put a couple more down here, plus 1, 1 subtract 1.4 squared, times 0.25, plus dot dot dot, plus the very last one, 4 subtract 1.4 squared times 0.05. We're going to find all of these terms. My goodness. Give me 1 second and I'll be right back. I'll switch to the intro again. I'll be right back. Okay, sorry for that pause. So where did I leave off? I wrote the terms out. We're going to find these terms using the calculator, and here's how we're going to do it. Let me just rewrite the formula here. The formula for finding the variance of a basic discrete probability distribution is the summation of x subtract the mean, in this case it's 1.4 squared, times your probability. Well, in the calculator, in the cells, I have the x values in L1. So I'm going to have L1 subtract 1.4 squared times, and my probabilities are in L2. So that's the formula we're going to put in, and it's going to give us each individual term. It'll give us this one, and this one, all of these, this one, and then I can come out of the cell sheet and add it all up. So let's go back to that now. Okay, so clear. Go back to my cell sheet, hit enter. I'm going to go to the top of L3. This is how we found our mean. I'm going to clear that out, hit enter. Scroll back up to L3 because that's where we have to put the formula. The formula I'm going to use here is parenthesis, because I'm going to have to put that square in there. So I want to have more parentheses. It's not going to hurt you. And if anything on a TI, it's going to help you from having an error in calculations. So I'm going to have second L1 subtract 1.4 close parentheses squared close parentheses times second L2. That's the formula. It's the same thing. In the formula, we have that capital sigma out front indicating summation. We're going to just do the summation. You can't put that in here. We're just going to find each individual term. We'll back out and add them all up. So I hit enter. There they are. Now I need to add each of these up. I can just, in one this small, I could just do it on the calculator if I wanted to, but I'm going to come out of here, just go to second, quit, I'm gonna go second stat, scroll over to math, scroll down to sum, and we're doing the sum of L3 again. I will say this, as an error, a front-loaded error analysis for you, always make sure that you were working in L3. Because sometimes I've done the mean in L3, moved on to L4 for the variance, and I forget where I put it in the moment of working it. So it doesn't happen very often, but it does happen. Enter. 1.44 is our variance. Okay, well, the mathematical relationship between standard deviation and the variance is just to take the square root of 1.44, enter. So 1.2 is our standard deviation, and we've got it. And we use the calculator to do it. Now, with that said, we set it up this way. Of course, it's gone now because I went out of it and came back in. That's one of the flaws of pushing this in Keynote instead of using Doceri. So I'm going to keep trying a few things till I come up with the right one. But so far, that's what I'm using tonight. So anyway, I hope that helps with this problem. We determined that this was a probability distribution. We found the mean. We found it manually. And we found it using the calculator cell sheet. Then we found the variance. We set it up manually. And then I put that formula. I set up the formula here. Then I put that formula in the calculator and found the variance there. Then I just took the square root of the variance. It's the same formula, just the square root of to get the standard deviation. Okay. Here's another one. We're going to do the same thing. First, we're going to determine if it's a probability distribution. I have to look up here. I'm sorry that the fractions are small if you're looking on from outside. So I've got 3/4 plus 1 divided by 10 plus 1 divided by 20, putting all these in parentheses, plus 1 divided by 25 plus 1 divided by 50 plus 1 divided by 100. Three-fourths, 1/10, 1/20, 1/25. What else have I got there? 1/50 of the 100. Yeah, I put them all out. So I got 0.97. So what I got right here, so the sum of my probabilities is equal to 0.97. And I'm going to say right off the top, that's too large of a discrepancy for me if I'm the researcher. Because those fractions are exact. And when I put those into the calculator, or if I did them on paper and found a common denominator, coming up with 0.97 is just a little bit too far off the mark for me. So I'm going to say that that is not a probability distribution. And then I'm going to move on. So, what's our next? The number of dogs. Okay, so we have the number of dogs per household. So in a small town, a group wanted to do a study concerned with how many dogs are in homes in this town. So they did a survey, or they actually went into homes and broke in and saw how many dogs there were. I don't know. But in this small town, there were 1,491 households that had 0 dogs. So there were 1,491 households that had 0 dogs. There were 425 households that had 1 dog. There were 168 households that had 2 dogs, 48 households that had 3, 29 households that had 4, and bless their hearts, 14 households had 5 dogs in this small town. We are going to build our probability distribution from this, and then I'm going to bust out to the calculator, and we're going to find the mean and the variance standard deviation. So first thing I'm going to do here is add up how many households there were, because proportionally I want to see how 1491 stacks up to the whole, how 425 stacks up to the whole, and so on. So we've got 1491 plus 425 plus 168 plus 48 plus 29 plus 14, and I get 2175. Oops. So I get 2,175 households were entered to check for dogs, or surveys were returned for dogs in this town. Okay. So I want to build the probability distribution. So here's how it's going to go. The distribution is going to look just like this, except we're going to look for the values for the random variable x in one row and the probabilities in another. I already know the values. If I randomly select a home, it could have 0 dogs, it could have 1 dog, 2, 3, 4, or 5. I can't exceed that. There's no home that I can randomly select that'll have 6 dogs, and I can't go less. You can't have a negative number of dogs. So there's the extent of what I can my possible outcomes for this particular experiment. So my probabilities look like the proportional pieces of this. In other words, 1,491 out of 2,175 homes had 0 dogs. Okay? 425 out of 2,175 had 1. 168 out of 2,175 had 2 dogs. 48 out of 2,175 had 3. 29 out of 2,175 had, that's actually showing up okay there. If you walk in the middle, it probably won't make sense, but as we're walking through, it looks okay. And then the very last one here was 14 out of 2,175. Those are going to be our proportional values from this table of data, are going to be our probabilities. So I've got 1,491 divided by 2,175. And I'm just going to round to 2 decimal places to keep my spacing okay. So I'm going to go to 0.69. Now with me rounding, when I add them up at the end, that the sum of the probability should be pretty close on either side. They shouldn't be as far off as we were in the previous. So for 1 dog, 425 divided by 2,175, 0.20. 168 divided by 2,175 equals, 168 divided by 2,175, 0.08. 48 divided by 2,175 equals 0.02. 29 divided by 2,175 equals 0.01. And the last one is 14 divided by 2,175, 0.01 as well. So when I add these up, 0.69 plus 0.2 plus 0.08, you can do it in your head, plus 0.02, 0.01 plus 0.01, I get 1.01. So my sum of these, the sum of my probabilities, is equal to 1.01, and I'm okay with that because I know I rounded, so I know it's going to be off a little bit, and that's not tremendously off. So I'm good with that. Okay. What do I do next? Well, we're going to find the mean of this. And if you remember, the mean, and let me put these numbers, God gracious, so I have 0 through 5, 0, 1, 2, 3, 4, 5. And over here I have 0.69 and 0.2, 0.8, 2, 1. For some reason the music was making a crackling noise. Sorry about that. So I've got my numbers in here. Here's what the setup is, just to remind you. To find the mean, we need to take the summation of the x values, which are 0, 1, 2, 3, 4, 5, we need to multiply those times the probabilities. And the probabilities here are 0.69, 0.2, 0.08, 0.02, 0.01 there. Okay? This is how we find it. So using our calculator, we're going to have, in L3, we're going to have the formula, in that L3, we're going to have the formula L1 times L2. It's going to fill in all my terms, and I'm going to find the sum. So let me back out of this, go here, stat, enter, go up here, clear, enter. Go up here, clear, enter, go up here, clear, enter. Then I've got 0, 1, 2, 3, 4, 5. That's good. Oops, enter. Then I have 0.69, 0.2, 0.08, 0.02, 0.01, 0.01. Here we go. So I've got all my numbers in here. 6928211. That's it. Scroll over to L3, and this is where I'm going to put my formula in. We're just looking for the mean. So I'm going to put second L1 times second L2. Enter. There are my individual terms. If I had written it all the way out, now I need to add them together. So I'm going to back out of here. Second. Hit clear. Second list, scroll over to math, sum of L3, 0.51. So 0.51 is my mean. Now I'm going to go back to the table, and we're going to use L4. Actually, no, we'll just use L3. Clear, I'm going to mix myself up. Whoops. Clear, enter. Now I'm going to find, I'm going to scroll up to L3, I'm going to find the variance. And the variance was, the formula was x minus the mean squared times the probabilities. You can fill in all the terms down below. 0.51 was our mean. Sorry, I had to remember. So 0.51. So I've got here, parenthesis, L1 subtract 0.51 squared, close the last parenthesis, times second L2. There's my formula. You got all the x values, subtract the mean, square them all the way down. Take that, multiply times L2 of the probability for each one of them all the way down. We're just doing it all in one step. Hit enter, fills them in. Now all I need to do is find the sum. Second quit, second stat, scroll over to math, sum of second L3, enter. So 0.853, let's say. And then to find the standard deviation, would just be mathematical relationship, take the square root, 0.853, enter, 0.92. Good enough. All right. There are a couple of problems, so it is 7:40. Let me I have not been looking at the chat, and I apologize. But it's only one person on. I'm logged in on my phone, so I'm the only person on here. So I will post this up to the Moodle. This is a few more examples like we did last week. Some slower, maybe slower walkthroughs, ones you can watch again to make sure you've got that. I'm not going to go back. It's 7:40. I've been on about 40 minutes minus the time that I went out there to try to figure out what the dog's barking at, which is only about 2 minutes. So I've been doing about 40 minutes, and I'm going to go ahead and jump off. But I appreciate anybody that came through and watched, and I appreciate anybody that comes back and watches the video. Hopefully it helps you a little bit. Help me in class and let me know if these help at all, if the video quality is okay. If you're not subscribed to this fantastic channel with dogs barking in the background, give me a subscribe or a like or a comment. Just let me know what you think. Is there ways to improve it? Just give me a comment. I'm not a monetary streamer, but it does make me feel good and sleep good at night to know that some of this goes towards people saying, hey, I could actually use that. So I am a teacher at heart. So I appreciate, again, anybody comes back and watch this video on demand, and I will see my class tomorrow night at 6 o'clock sharp. Quiz tomorrow night, don't forget it. And then Thursday, I will do another online office hours at 7 o'clock. Thanks.